Hello. Now, I want to talk about this unit. What you need to pay attention to and how to start it properly so that um, everything goes as it should during spraying. So let's start with the first thing. You know how to turn it on. This is how I turn it on, right? You know the temperature as well. So starting up the unit. How do we start working with the unit? We've connected the air here, 6 bar. We turn it on. The air is flowing. We turn on the unit. If it's glowing green, it means our pressure is fine. The unit should be getting some have 7 bar, some have 8 bar. But here it should show 6. Why? Because the crucial pressure valve that's precisely located inside the head right here, specifically within this particular headed, absolutely requires a precise 6 bar, or more accurately, 6.2 bar of pressure. However, if you were to supply it with an excessive 8 bar, it would still technically function. But then you would inevitably encounter undesirable gas dynamics and significant heating, which would consequently cause the operational speed to dramatically increase. So that is certainly not a really good or optimal situation. Therefore, with 6 bar applied here, it's visibly glowing a vibrant green. Everything is perfectly great and functioning as intended. Next, we will now proceed to carefully turn on the temperature. Subsequently, we will precisely set the powder feed. This particular setting can be configured to 1, 2, or even 3, but we will definitely come back to discuss that specific aspect separately and in more detail. We finish the work. That is, we turn off the heating, but leave the air on for a bit to cool down the heating element, the heating coil, for about a minute. Then we completely shut off the air supply. That's the end of the process. Next point. About the powder. The powder is drawn in, that is sucked in, using injection. This nozzle here creates the injection for us. I sent you earlier how it works in the photo. So when we turn on the air and fully open the valve, the air flows through, and here it creates suction. So when we connect this hose here, we've connected it, it starts to draw in powder through these holes. That's why you need to check here how good our injection is, how effective it is, whether it's good or bad, or if it's not working at all. So if there's no injection, there's no point in supplying more or less powder, because the powder is delivered by means of the injection. It's just a tube through which it draws in our powder. So whether you increase or decrease it here, nothing will change. If there's no injection, the powder will just spill out. Why? Because we pour it into this flask. There's an electric motor here that vibrates, and this vibration makes the powder fall down here. It pours out, and the injection draws this powder into the tube. Then it travels through the tube to our nozzle, and then it goes to the element that we're coating. What are the nuances? You shouldn't set the powder feed to 5, 6, or 7. There's no point, because it already pours well. It's designed so that it pours well at level 2 or 3. If you set it higher, you might not keep up. So how does this happen? If you set the dispensing level too high, for instance, to a setting like 9 or even 7, a truly enormous amount of powder will inevitably pour out and then efficiently travel through this wide, expansive tube, primarily because the tube's internal diameter is exceptionally large. So the precise diameter of our tube, let's consider it to be approximately 4.5 millimeters. The significant problem that arises is when a substantial amount of powder is actively moving through this particular section. And this specific part here becomes heated up. If you observe very closely, the aperture or the opening here is quite small. It's about 1.5 to 1.8 millimeters. And when a large amount of powder is flying through, it just slams into this spot like a fist and blocks it, simply clogs it up. That's why the injection stops working. You press the powder feed button, the powder pours out, but the injection doesn't draw it in. So there's absolutely no point in cranking this up to the maximum or setting it to 5. That's an important point and nuance to keep in mind. The opening here is very small, right? If you compare this opening to the diameter of this small hole, they're very different. So there's no need to set it to the maximum, it won't do you any good. Next point, if you need to blow through it because something is clogged or whatever, then yes, do as you did, blow air through it, but don't use too much pressure, because here, where it switches in one direction or the other, the tubes can come off since there shouldn't be any pressure there at all. And if you blow into it with full force because you did something wrong, the tubes can come off as well. The hose is not designed for high pressure. If it can handle a couple, if it withstood 1 atmosphere, well, that's good. Otherwise, you could just cause damage. All right. The next point is that you work at temperatures of 5, 6. You can even work at a temperature of 7, meaning you set the powder feed to 1 or 2, and you can play around with the temperature. You just see how quickly the powder starts to build up at high temperatures, at 7 or 6. The lower the temperature you set, the slower it grows, but it has a very high density. And this density allows us to work with air conditioner tubes that no longer let freon gas through. So keep that in mind. The next point is this part right here. When you insert the tube, you need to insert it all the way in and tighten it. It needs to be rotated a few degrees after 80 to 150 grams of powder. That is, the powder went one way, you unscrewed it, changed the angle, and screwed it back on. Because the powder is very sharp and it just eats a hole through here. But I think you've already encountered this. Next point. The next point is the coating on the part. So you're applying the coating to the disc you have. And what would I like to show or explain to you? Let me draw it for you now. Is the disc you have, it has pores, meaning small holes. But here's a big pore. Yes, this one. But there are also very small ones. Well, they look like this, right? This is a pore. You apply the coating with your setup. Now, if this is the nozzle, but the nozzle will look like this. Here it is. The powder is flying. And it won't be able to get in here. Because the hole is very small. Due to gas dynamics, turbulence, it simply can't get in here and fill all of this. It just can't. So what should you do? In such specific and precise cases, I carefully take a powerful drill and meticulously proceed to make these necessary holes, these distinct and deliberate openings, exactly like this, ensuring they are perfectly aligned and size for the intended purpose. And in this case, you can coat this opening because with small holes, due to gas dynamics, the powder simply won't get in. That is, it will build up here. You'll use up a lot of powder here, but it won't get in there. In this case, here you can coat it without any problem. Or here too, there's a hole, and you can coat it here as well. Okay, but if the hole is very small, like here, like yours, then it will be difficult to coat it. In any case, you need to make a chamfer with a small drill to create this kind of angle in the hole. That's all. So you set the temperature to 5 or 6 as you usually do, no 2, and check the injection here. If your injection is poor, the powder doesn't get sucked in well. You can unscrew this part if needed, or take a look like this, right? Pull it out, check the condition here. You'll be able to see this whole, well, part, half of the hole. That's it. If it doesn't work, then unscrew this part. Because when you're working and you give though, the part is already heated up and you give a large amount of powder, just imagine, right? It flies in aluminum, but not just aluminum, there are different various metal contents in the powder, and it just gets embedded into the hot part, into this small hole, and simply gets stuck. It clogs it up like a cork, and your injection can decrease. The same goes for the tube. If you haven't inserted this tube all the way in, if it's just a little bit short of fully seated, your injection will also be lost, because all the calibrated holes here are precisely calculated. Well, that's basically what I wanted to show you. Always carefully check the device on any stable, flat surfaces before use. That is, you can take a pipe, you can take a piece like this, right? You can take a piece of aluminum and just check how the powder grows on a regular flat surface. If it grows well on a regular flat surface, then you don't have any problems with the coating. If you can't coat the inside of a hole, then you either need to change the angle of the hole, or you can slightly increase the temperature and try to coat it again. You need to take gas dynamics into account, and you should always keep that in mind. Gas dynamics.